This is chapter number 15, which is waves. We are talking about question and answer on waves. A string of mass 2.5 kg is under a tension of 200 Newton. The length of the stretched string is 20 meter. If the transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other end? So what all is given to us? Mass is given, the tension is also given, the length of the string is given. We know that the mass per unit length is what? This mass divided by length. So this is mass per unit length. And we also know that the velocity of the transverse waves in the string is given by the relation V equal to under root T by mu. T is what? Tension. And mu we just found out. Just put it here. It will be 40 meter per second. Now, the time taken by the disturbance to reach the other end, we know speed equal to distance by time. So we have to find out the time. So we have to divide distance by speed. That is, distance here in this case is L. The velocity we just found out. So L by V. This L by V. L is 20 and this meter. And then we divide it by 40. So it gives you 0.5 seconds. A stone dropped from the top of a tower of height is given. Height splashes into the water of a pond near the base of the tower. When is the splash heard at the top, given that the speed of the sound is this much? So what is happening here is from the top of the tower, a stone is being thrown and the voice is heard here. So height of the tower is given, the initial velocity, because it is starting from the rest, so we take u equal to 0, and the acceleration, of course, when it is dropping, it is gravity, it's 9.8 meter per second square. Then the speed of the sound in air is 340 meter per second. Now this t1, let us take t1 is the time from this point to this point, that is, it is coming down, that is the stone which is striking the water in the pond. We can use the second equation of motion, that is s equal to u t1 plus half gt1 square. And when we put the values which are given to us, s is 300, initial velocity 0, gravity 9.8, t1 we don't know. So t1 can be computed by this expression, 7.82. Now 7.82 is from this point to this point. Now the sound has to go back to here. Now this time taken by the sound to reach the top of the tower is what? The distance is again 300 only, and this is the speed of the sound. So 300 by 340, this is t2, this is t1, this is t2. So this is the first one is the time taken from here to here, second is the time taken for the sound to go from this point to this point, top of the tower. This is 0.88. We add these two, we get 8.7 seconds. A steel wire has a length of 12 meter and a mass 2.1 kg. What would be the tension in the wire so that the speed of transverse waves on the wire equals the speed of sound in dry air? The temperature is given and the speed is also given. So the length of the steel wire is what? 12 meter. The mass of the steel wire is 2.1 kg. The velocity of the transverse wave is also given. This is 343. The mass per unit length we have to find out. This is mu. This is mass per unit length. So mass you take per unit length divide by 12. So this gives you mass per unit length, that is 0.175 kg per meter. For a tension T, the velocity of transverse wave can be computed using V equal to under root T by M. So this is T by M, and if we want to find out this T, this is V square, we have to square it and multiply with mu. So V square into mu, because V is given to us. So we multiply this V square with mu, we just found out this mu. So multiply them, you get 2.06 into 10 to the power 4 Newton. Use the formula this to explain why the speed of the sound in air is independent of the pressure, increases with volume, increases with humidity. So the scenario is this V has gamma P and rho, pressure, density, gamma. So this density is what? Rho is given by mass by volume. We know that mass by volume, we can say mass is equal to density into volume. So m here is the molecular weight of the gas and V is the volume of the gas. So this equation becomes what? Let us put m by V here. So this becomes V equal to gamma PV by m. Now for ideal gas equation, if we have some n equal to 1, this PV equal to RT. We know that PV is equal to mu RT. We are stating that this mu is 1, number of moles. Let us take it as 1. So eventually this PV is constant if this temperature is constant, because P on the right hand side, this is universal gas constant. This T we are taking as constant. This is constant T. So PV will be constant. So both M, gamma, these are constant. We know that these values are always constant. So velocity will be what? If this is constant at constant temperature, gamma and M are also constant. So this velocity becomes constant value. So at constant temperature, the speed of the sound in gaseous medium is independent in the change of pressure. So if we have taken this relationship, and again for 1 mole, we'll again take this relation mu equal to 1. What is P? P is given by, P can be written as RT by V. Now again substituting this second in our first equation, that means this equation, we are putting RT by V in place of this P. So this becomes gamma RT by rho into V, and we know that rho into V, that is density into volume, is mass. So gamma RT by M. Here, because see this mass will remain constant, rho into V. So what we get? Gamma RT. The gamma RT, gamma and R are also constant. These two are constant. So now we conclude from this that V is essentially directly proportional to the under root of temperature. The speed of sound in gas is directly proportional to the square root of the temperature of the gaseous medium. That means that the speed of sound increases. This increases with increase in temperature in gaseous medium. Let us take now Vm and Vd, V sub m and V sub b. These are the sound or speed of sound in moist air, and this is the dry air. So this rho m and rho d, these are the density of moist air, rho m, and this is the dry air. So let us take this relationship, this V equal to under root gamma P by rho. First, the speed of the sound in moist air. So let us replace this rho by rho m, and the speed of sound in dry air, we replace this rho by rho d. When we divide these two equations, this one and this one, when we divide these two, we get Vm by Vd, and most of the things gets cancelled. This is rho d by rho m. So you see that Vm is inversely proportional to rho m and Vd is inversely proportional to rho d. So the presence of water vapor will reduce the density. That is, this rho d is less than rho m, and when this rho d is less than rho m, we say this, because they are inversely proportional, Vm is greater than Vd. So the speed of sound in moist air is greater than its dry air. So in a gaseous medium, the speed of sound increases with humidity. You have learned that a traveling wave in one dimension is represented by this function, y equal to f x comma t. X and t, they must appear in certain combination, x minus vt, x plus vt. Now y equal to f x plus minus vt, this is given, is the converse true? Means is the if you backtrack it, is the reverse true? We have to examine these functions for y, which can possibly represent a traveling wave, all these. So first of all, the answer for this question is no. Then these are, they do not represent a wave. This do not represent a wave. This represent a wave, and this does not represent a wave. So the converse, we are saying that it is not true. What is the essential requirement? The essential requirement for a function, this function, any function to represent a traveling wave, is that it should remain finite for all values of x and t. Okay, let us take the first one. For x equal to 0, you put x equal to 0 and t equal to 0. What will this will be? It will be 0. For x equal to 0 and t equal to 0, the function will represent a point. It is representing a point. It is not a wave. For x equal to 0 or t equal to 0, for this one, let us put x equal to 0, t equal to 0. You see, this becomes 0, and this log 0 is infinity. And since the function does not converge to a finite value at x equal to 0 and t equal to 0, it represents a traveling wave. For this one, x equal to 0 and t equal to 0, again it is 1 by 0, that is infinity. So since this function does not converge to a finite value, for this x equal to 2 and t equal to 0, it does not represent a traveling wave. I hope you got the idea. A bat emits ultrasonic sound of frequency this much, 1000 kilohertz in air. If the sound meets a water surface, what is the wavelength? First, of the reflected sound, second, the transmitted sound. The speed of the sound in air is given and water is also given. So here the frequency of the ultrasonic sound is 100 kilohertz, that is 10 to the power 6 hertz. Now what is the speed of sound in air, which is also given in the question? The speed, we know that V is equal to nu lambda. Nu is frequency, lambda is wavelength. So if we want to find out lambda, lambda will be V by nu, that is frequency. So this is V by nu. So the wavelength of the reflected sound is given by this, as I told you, this is V by nu. V is the velocity and nu is the frequency. This is the frequency. So what you get? Lambda. We got the lambda here. Now the frequency of ultrasonic sound, again velocity V will be, this frequency will be 1000 kilohertz, that is 10 to the power 6 hertz. And the speed of the sound in water, what will be this? This is given 1486. Again we'll do the same thing here as we did here. So 1486, in this case we'll use V as 1486. 1486 by 10 to the power 6 is 1.49 into 10 to the power minus 3. So first case is this one, second case is this one. A hospital uses an ultrasonic scanner to locate tumors in the tissue. What is the wavelength of sound in the tissue in which the speed of sound is 1.7 kilometer per second? The operating frequency of scanner is this much. So what all is given? The speed of the sound in tissue is given like this. We'll convert this kilometer into meter. It will be 1.7 into 10 to the power 3. The operating frequency of the scanner is this much. This is in megahertz. Convert into hertz multiplied with 10 to the power 6. Now when we know that V equal to nu lambda, or lambda is given by velocity by V. V is equal to nu lambda. This lambda is simply velocity by frequency. Velocity is this much, frequency is this much, divide these two, you get this value. A transverse harmonic wave on a string is described by this equation. Yx comma t is 3 sine 36t plus 0.018x plus pi by 4. This x and y, they are in centimeter and time in second. So the positive direction of x is from left to right. The question is like this: is this traveling wave or a stationary wave? First of all, if it is a traveling, what are the speed and directions of its propagation? What is amplitude and frequency? What is the initial phase at the origin? And what is the least distance between two successive crests in the wave? First is, these are the answers. We are going to give you how we came across all these. This is just for your, just to have a look. Now see, first of all, we have to compare this with the original, or the you can say the proper equation form. The equation of progressive wave traveling from left to right is given by the displacement function yx comma t is a sine omega t plus kx plus phi. Now let us equate. A is what? 3.0. Sine is sine. Omega t. So omega is what? 36. Kx. This is k, 0.018. Phi is what? Pi by 4. So when we compare this equation, we find that this is actually a traveling equation which is propagating from left to right. And when we compare this, we found that omega is 36, k is 0.018. Now we know the relationship, that is V equal to, that is omega equal to 2 pi nu, and also this lambda is 2 pi by k, and also V equal to nu lambda. Nu is the frequency. Now let us use this. V is omega by 2 pi, and in this place we'll use 2 pi by k. See, omega 2 pi, here we will use this value, here we will use this value. So what velocity becomes? Velocity becomes omega by k. Omega is known to us, we have compared it with the actual equation. K is also known. So this is 2000 centimeter per second. You can convert it into meter per second. Now the speed of the wave we just found out to be 20 meters per second. The amplitude of the given wave, as you compare with the equation, this is amplitude. So amplitude is 3. So now this amplitude, because it is 3, the frequency of the given wave will be what? Frequency, which I just told you about this the omega by 2 pi. Omega is 36 as you compare with the equation, actual equation 2 into pi 2 into 3.14. This is 5.73. Now when you compare these 1 and 2 equation, we also found out that phi is pi by 4. Let me tell you again. What is this phi? Phi is this pi by 4. So here phi is pi by 4. So the distance between two successive crest and trough is what? Is actually the wavelength. Crest or trough, this is lambda, right? So what is the wavelength? K equal to 2 pi by lambda. With this expression we know 2 pi, and this K we can just put the value K as we compared it with the equation. So 2 into 3.14 by K is lambda. This is 3.49 meter. For the wave which we just described in the previous discussion, plot the displacement y versus t graphs for x equal to 0 to 4. What are the shapes of this graph? In which aspect does the oscillatory motion in the traveling wave differ from one point to another? Amplitude, frequency and phase. So this was our equation. All the waves have different phases. The equation is like this. Now at x equal to 0, you just have to put x equal to 0 here. Put x equal to 0. What this will become? Y0 comma t will become, this will become 0. It will be 3.0 sine 36t plus pi by 4. We know that omega is 2 pi by t, which is actually, if you compare it here with omega, this is 36. So omega 2 pi by t is 36. So 2 pi by t is 36. What is the t then? It is pi by 8 second. So when we plot the y versus t, we have different values of t you have to give in this equation. So when you put t equal to 0, you get y equal to 3 root 2 by 2. As I said, you just have to put different t values in order to get this y. So when we are putting different t values, we are getting different y. And for x equal to 0, x equal to 2 and x equal to 4, the phases of these three waves will get changed. How? First you have to plot this t with y. Say for t equal to 0, from at t equal to 0, what is y? 3 root 2 by 2. So this is 3 root 2 by 2. At t equal to t by 8, if this is t by 8, you have to put y equal to 3. So what is 3? Here. This is the point. This is how you make the graph. So for all these, this is for 1, we have to find it for x equal to 2, x equal to 0, 0, 2 and 4. So there will be three waves like this. So phase of three waves will get changed. Why? Because the amplitude and frequency are invariant of any change in x. So the yt plots of these three waves are shown like this. I hope you got the idea. You have to do it for x equal to 0 first, then x equal to 2. So firstly this red will come. For x equal to 2, the second will come. X equal to 4, the third will come. And you have to take the x-axis like this, t by 8, 2t by 8, 3t by 8, and the y, of course, you can take any 1, 2, 3 divisions. For the traveling harmonic wave, yx comma t is given by this. So where this x and y are in centimeter and t is in second, we have to calculate the phase difference between the oscillatory motion of 2 points which are separated off by this and this. So the equation is like this: y equal to 2.0 cos 2 pi 10t minus 0.0080x plus 0.35. This equation is what we have written. Now this is the equation which we can write this in certain form. See, this is cos 2 pi, multiply 2 pi inside, 2 pi inside and 2 pi inside. So we can get, because we don't want this 2 pi outside, let us it be inside. This propagation constant k is what? This k is this one, 0.0. When we compare it with the a cos kx, this omega t minus kx plus pi. So when we compare it, k becomes 0.0160 pi, this one. And when you compare the amplitude, see, the amplitude is 2. Amplitude is also known to us. And then angular frequency omega is of course 220 pi. Omega is this 20 pi. This is omega 20 pi. And the phase difference is given by what? Phase difference is simply k into x or 2 pi by lambda. If you take x equal to 4 meter, or you can take it as centimeter, 400 centimeter, the phi will be given by what? You just have to place the value. K is known to us, x is 400. For 0.5, again, this is the k value, put 50 here in centimeters. So you get these two phi. Now for x equal to lambda by 2, if x is lambda by 2, then what will be your phi? 2 pi by lambda into lambda by 2. Okay, 2 pi by lambda and lambda by 2, which gives you pi radian. For x equal to 3 pi by 4, what will be phi? Again 2 pi by lambda into 3 pi by 4, 3 lambda by 4, lambda cancels, it gives you 3 to the 6, 6 pi by 4, which is 1.5 pi radian. This is how it gets. The transverse displacement of a string which is clamped at its both end is given like this. 5 y x comma t is given like this, where x and y are in meter and t is in second. The length of the string is 1.5 meter. Mass is given as 3.0 into 10 to the power minus 2 kg. We have to answer certain thing. Does the function represent a traveling wave or a stationary wave? You have to interpret the wave as a superposition of two waves which are traveling in opposite directions. And what is the wavelength, the frequency, the speed of each wave? We have to determine the tension in the string as well. See, the general form of any stationary equation is given by a displacement function yx comma t is 2a k sine kx cos omega t. If you see, these two are matching somewhat, so the equation is similar to this equation. Now we compare. This 2a is equal to 0.06, k is equal to 2 by 3, omega is equal to 120 pi. So everything is being known. If we compare, the given function represents a stationary wave, and a wave which is traveling in positive x direction is given by what? y1 a sine omega t minus kx. We know about this, you learned in theory. So which is the wave which is traveling along a negative direction will be what? Minus a sine omega t plus kx. So this is y1 and this is y2. So y2 is given by this. So if you want to find out the superposition, you add y1 with y2, this term with this term. So it gives you a sine omega t minus kx minus a sine omega t plus kx. So when we take a common and sine a minus this sine, you can expand it also, sine a minus b. So sine a minus b and sine a plus b, you have to expand it, something gets cancelled, things will be cancelled, only this will be remaining, 2a sine kx or cos omega t, which is essentially k. You can write, we know that k is nothing but 2 pi by lambda. You can represent k by 2 pi by lambda. Omega, we know it is 2 pi into frequency, so you can write 2 pi frequency. So the transverse displacement is this equation. Now we are comparing. This 2 pi by lambda is given by 2 pi by 3. Compare it. The wavelength easily can be computed, right? The wavelength can be computed. And when we compare this 2 pi frequency, 2 pi nu by 120 pi, if you compare it, the v becomes pi cancel, 2 divided by 120 is 60, so v is, means frequency is 60 hertz. We know v equal to n lambda or nu lambda. We can find out the velocity, which is 60 into 3, which is this one into this one, because lambda is 3, we found out from here. So this is 180 meter per second. Now the velocity of transfer wave which is traveling in a string, we know it is given by under root t by mu. Now velocity is known to us, 180. The mass is also given in the question. The length is also given in the question. The mass per unit length is given by m by l. We have to find out m by l. M is also given, L by is also given. Divide these two, you get mass per unit length, that is mu. Now T is the tension and we have to find out the tension. Let us square these two sides, means V square and this square. So you get V square equal to T by mu. You have to find out T, so take mu here. So V square into mu. V is what? V square, this is 180. 180 whole square, this is velocity. And mu is what? We just found out this value. Multiply these two, you get tension as 648 Newton. So this is the first part of our discussion of question answers on this topic. We'll be taking one more. Till then, thank you so much. Take care of yourself.